When you type the word unbelievable into ChatGPT, the AI doesn't see one word. It sees 3 pieces. Those pieces are called tokens, and they're the real language AI speaks. You might think, why not just feed the AI individual letters? A single letter carries almost no meaning. C doesn't mean anything, A doesn't mean anything, T doesn't mean anything, but the AI has a limited attention span. It can only look at so many pieces at once. This is called the context window. If every letter was its own piece, the sentence, "The cat sat on the mat," would eat up 22 slots just for 6 words. That's incredibly wasteful. We need bigger, smarter chunks. Okay, what about whole words? That's better, 6 tokens instead of 22. But here's the problem. Running, runner, runs, ran. If every form of every word is its own token, you'd need millions of tokens to cover English. And what happens when someone types a word the AI has never seen before? It just breaks. So the real answer is somewhere in the middle. Not letters, not whole words, subword tokens. The tokenizer learns the most common patterns from a massive pile of text. Common words like "the" and "cat" stay whole. They're so frequent they earn their own token, but longer or rarer words get broken into reusable pieces. Un is a super common prefix. Able is a super common suffix. The tokenizer learns these building blocks so it can handle words it's never seen before by snapping together pieces it already knows. This is why you hear about context windows measured in tokens, not words. When someone says a model has a 128,000 token context window, that's roughly 96,000 words, about the length of a full novel. Every token costs money and attention. The AI processes every single token in the window to generate the next one. More tokens means more compute, more time, more cost. That's why efficient tokenization matters so much. Better tokens mean you fit more meaning into the same window. Tokens also explain some of the weird things AI does. Numbers often get split in strange ways. The AI isn't seeing the number 42,857. It's seeing 2 unrelated chunks. That's why language models are notoriously bad at math, and different languages tokenize differently. English is very efficient, roughly 1 token per word, but some languages need 3 or 4 tokens per word, which means they use up the context window much faster. Remember embeddings from episode 1? Each of those points in space? They're not words, they're tokens. The tokenizer chops up your text and the embedding model turns each token into a point. Tokenization is step 0. Everything else in AI starts here. That's tokens, the atoms of language models, not letters, not words, the smart pieces in between. Next time, how the AI actually reads all those tokens at once. That's attention. See you there.